Good morning. As a part of the value-added course on data analytics using Python, in Module 3, we are going to discuss about NumPy and Pandas. So today our discussion will be on the Pandas library. So introduction to Pandas. Today our discussion will be importing data into Spider, creating copy of the original data, attributes of data, indexing, and selecting data. Introduction to Pandas. It provides a high performance, easy to use data structure and analysis tool for Python programming language. Pandas is an open source Python library providing high performance data manipulation and analysis tool using its powerful data structure. The name Pandas is derived from the word panel data, an econometrics term for multi-dimensional data. So Pandas is a library, powerful library available in Python for manipulation and data analysis using multi-dimensional data. So Pandas deals with the data frame. Data frame is a two-dimensional data structure which is size mutable, and it is potentially a heterogeneous tabular data structure with labeled access for rows and columns. So we'll now look at the procedure for importing data into Spider. So the data can be available in any format like text, Excel format, and the CSV format, and so on. These file formats can be imported into Pandas so that you can perform data analysis. So for that, you need to import some library files like OS, Pandas, and NumPy. And OS is used for the purpose of using to change the directory and operating system related functions. And Pandas is the library you'll have to import in order to perform data analysis using Pandas. And we have discussed NumPy earlier. So the Pandas work in combination with NumPy. So you need to have the NumPy also. So you can import it. You can using import OS and import Pandas as PD and import NumPy as NumPy for numerical calculations. So .os.change directory will change the working directory to Pandas, where we are going to perform all our operations with respect to Pandas directory alone. Now coming to importing the data into Spider, we are going to use a file called Toyota CSV. It is a file which is containing information about the pre-owned cars. And this file, we are going to import it to the Pandas environment by using a command called read CSV file. So pd.read CSV is a command used to convert this Toyota.csv into the data frame called cars underscore data. So now once it is imported into the Python environment, you call it as a data frame, and the name given for this data frame is cars underscore data. Right. So when you execute this command, you will have this particular table shown that Toyota CSV file is converted into a cars underscore data data frame to be used in Python environment. Now we see there are two columns, index and unnamed 0, repeated. So their index is being repeated in the unnamed 0. So we can remove this particular column by using a command called index underscore column is equal to 0. So by passing this command, the first column becomes the index column. So the command is pd.read CSV, the file name Toyota.csv, comma followed by the command index column is equal to 0. So when you execute the command and store the result in same data frame name, now this unnamed column is removed and you are going to have only first column as the index column. creating a copy of the original data. So in order to perform the data analysis, you are going to have a copy of the data, so that if you want to compare it with the original data, you will be having a copy. So there are two types of copy available, that is shallow copy and deep copy. Where this shallow copy, you are going to have a temporary collection. That is, it creates only a new variable that shares the reference of the original object. So any changes made to the copy of the object will be reflected in the original object. So both the copy and the original file will have the same content in the shallow copy. Suppose if you want to have a deep copy, a separate copy can be created using a deep copy. In this case, a copy of the object is copied to another object file with no reference to the original file. So any changes made to the copy of the object will not be reflected in the original object. So that's the difference between these two type of copying, called shallow copy and deep copy. Now coming to the attributes of data. Now that you have imported the data from the CSV file to Pandas data frame, now we can find out what are the attributes of data. So there are various parameters available. The first parameter is index. So data frame.index is a command used to find out how many number of rows are there in the particular data frame. So to get the index, that is the row label of the data frame, so you can use the cars underscore data one, the file name dot index will give you the row label. So the row label starts from 0 to 1435. So there will be a total of 1436 rows available in this particular data frame. The next attribute of data is column. So now that you have found out how many rows, to find out how many columns and what are the columns available, we are going to have this data frame dot columns. To get the column label of the data frame, cars underscore data one dot columns. If you execute this particular command, you will get what are the columns available. So the column names are going to be price, age, kilometer, fuel type, metallic color, automatic, CC, door, weight. All these are the columns available in the data frame called cars underscore data one. So that is being available in the command cars underscore data one dot columns. So the next attribute is going to be size and shape. So to find out the size and shape of the data frame, there are two commands, data frame dot size and data frame dot shape is used. Size will give you the number of rows into number of columns. So you had 1436 and 10 columns. If you multiply, you will get this particular value, the size of the data frame. And shape of the data frame is nothing but the dimensionality of the data frame. So cars underscore data one dot shape will give you the dimensionality. So 1436 rows with 10 columns is the shape of this particular data frame. And the next attribute is memory usage. How much memory is being used by the entire data frame. So data frame dot memory usage is a function used to find out the memory usage of each column in bytes. So cars underscore data one dot memory usage. This is the command. If you execute it, you will have these information. So this information shows that each column, how many bytes are being used for storing the information of the data frame. And similarly, data frame dot ndim will give the dimensionality of the particular data frame. So to find out the dimensionality, so cars underscore data one dot ndim will give you 2, which means the cars underscore data frame is a two-dimensional data frame, a two-dimensional array which stores data in the format specified with rows and columns, and each column having its own column heading. The last part of today's session will be on indexing and selecting the data. Python uses a slicing operator called square bracket. And similarly, for attribute, you have a dot operator for indexing. So slicing operator and indexing operator, these two provides a quick and easy access to Pandas data structure. So indexing and selecting of data, under selecting of data, you are going to have a dot head, which will give you the top n number of rows. So to find out the top n number of rows, data frame dot head within bracket, the n is optional. You by default, if you do not specify anything, first 5 rows will be selected. Or if you want to have specific number of rows, you can specify the number of rows here. For example, cars underscore data one dot head of 6 will give you the top 6 rows available in the data frame. And if you are not going to specify the 6, first 5 rows will be displayed by default. And tail will give you the same from the last. So the last n number of rows can be displayed using the tail function. So cars underscore data one dot tail 5 will give you the last 5 rows available, so that you can see whether the entire data frame has been imported properly and so on. So it is useful for quickly verifying the data, and you can check after sorting and appending of rows whether it has been sorted properly till the end of the data frame. So indexing and selecting of data can also be done using the scalar value, using a fastest way by using a 2 commands called at and I@. methods. At provides label-based scalar lookup. For example, if I want to find out 4th row in the column name fuel type, what is the value available, I can select the data by specifying cars underscore data 1, the command dot at, followed by the row and the scalar value that is going to be available for the column type. So 4th row under fuel type, what is the value? And you get the result diesel. So fuel type, you have diesel, petrol, gas, and so on. So under this row, you have this value diesel. And similarly, if you want to have an integer-based lookup, so if you want to specify the row number and column number, you can use I@. So the same command, cars underscore data 1, I@, you can specify 5th row, 6th column, and it is going to give you the value. So for scalar type, you are going to use the at command. For integer-based lookup, you can use I@. command. So you can specifically go to a particular row and column and find out the value available there. Indexing and selecting of data can also be done by .loc command to access a group of rows and columns. So if you want to specifically use one value, you used at and I@. command. If you want to have a group of rows and columns, then .loc command can be used. For example, this cars underscore data .loc. This colon means you fetch all the elements of the row to a particular column called fuel type. So for one column alone will be selected. If you want to have multiple columns, you can have a comma separated value given for all the type of columns. It will display the selected column alone. So if you want to have a group of rows and columns selected, you can do it by means of having a indexing and selecting of data. So far in this lecture, we have discussed about the introduction to Pandas. It is an important library available in Python for performing data analysis. And we have learned the method for importing data into Spider and how to create a copy of original data in terms of deep copy and shallow copy. And we have also discussed about the attributes of data. And we have also discussed about indexing and selecting of data. Thank you. We will see in the next video.